Lakshmi, Assistant Professor in the Department of Mathematics, SNS College of Technology. This is the lecture video series on the course Matrices and Calculus, and now we are on to the topic Volume of Solids using multiple integrals. This video is purely based on the design thinking approach of multiple integrals. Here we are going to study a problem which will be implemented with the help of design thinking. Our students are going to explain it.
Now I am going to explain about the real game application. So design of an underground water storage tank is an example for this. And modern campuses, industries and small cities use underground water tanks which are shaped in paraboloid shape or also known as curved shapes to withstand soil pressure, minimize material usage and maximize storage capacity. We can't use the normal volume formulas in this, so we use triple integral formula and you use the triple integral formula to find the water.
Okay, this is commonly used in civil and mechanical engineering designs. This is what we have got as a real-time application.
Empathize is the first stage of design thinking. In the empathize stage, we focus on understanding the real needs of the users and the problem. Here, due to water scarcity, there is efficient essential of storage tanks. So, engineers must have accurately calculate the volume of those storage structures to plan capacity and reduce cost. And most of the structures are irregular in shape, so they are not calculated by simple formulas. Therefore, there is a need to use multiple integrals in those problems to calculate those volumes.
Define is the second stage in design thinking. So define means understanding the problem before solving it. And here we have to find the volume of underground water tank bounded by the paraboloid. Z is equal to 4 minus x square by minus y square, and the plane is Z is equal to 0.
So here we are going to find the volume of the tank using multiple integrals. This is what we are defining the problem here using design thinking.
Design thinking, the best way to solve the problem is that to find the volume of the solid, we use a triple integral. Because the shape is cylindrical, so we use that. Normally using this x and y coordinates becomes somewhat complicated. So we use the cylindrical coordinates which comes from polar coordinates. Here this r is the radius, theta is the angle and z is the height. The small volume element dv is equal to r, dr, d theta, dz. This makes the calculation simpler and easier.
So this is stage of design thinking approach.
So in design thinking it's prototype. So in this we have to set a limit for integration. We are setting a limit for z range from 0 to 4 minus r square. Then for second we have to put z is equal to 0. Then we get a limit from range r is equal to 0 to r is equal to 2. Then for theta it is 0 to 2 pi 180 degree. And we are substituting the limit in this. We get t equal to integral 0 to 2 pi integral 0 to 2 integral 0 to 4 minus r square or dz dr d theta.
So using the polar coordinates in the ideation process, we are just defining the limits of the concepts here. So first limit, inner limit corresponds to z, the next limit corresponds to r, and the next limit corresponds to theta.
Test part from design thinking. Integrate with respect to z. Integral 0 to 4 minus r square dz, which is equal to 4 minus r square. Now substituting this value in the volume. V is equal to integral 0 to 2 pi integral 0 to 2 r into 4 minus r square dr d theta. On simplification we get integral 0 to 2 pi integral 0 to 2 4r minus r cube into dr d theta. Next integrating with respect to dr. Next slide. So which is equal to 2r square minus r power 4 divided by 4. Upper limit is 2 and the lower limit is 0. On simplification we get V is equal to integral 0 to 2 pi 4 d theta. Now integrating with respect to theta, we get V is equal to 4 into upper limit is 2 pi and the lower limit is 0. On simplification, we get V is equal to 8 pi cubic units.
So final answer on the volume of the tank as such we have found is volume is equal to 8 pi cubic units.
As discussed in the first slide, the tank can store 8 pi cubic units of water. So engineers can estimate daily water supply, navigate construction material, and optimize shape for strength and capacity.
So this is what we have implemented in the as the engineering solution using our design thinking approach. This is the final stage of design thinking approach where we are going to implement what are the key takeaways here. This is going to be explained by our student.
So most real objects are three-dimensional and often in irregular shapes. So simple formulas are not sufficient to calculate them. So we use triple integrals, and triple integrals also helps us to compute volume, mass and energy. They also helps us to design tanks, domes, reservoirs and fuel containers. And triple integrals also connects mathematics with real engineering decisions such as bridge designing and planning structures.
So engineering decisions can be made with the help of these triple integrals also. This is what we have learned using the design thinking approach. Thank you.